we are now going to learn what type of CNM network we are going to use based or choose based on the use case. So let me show how to choose a router networking network type based on the use case. Listen carefully. Now let's start from the basic none network. Okay, so let me start it with a small choosing Docker CNM. So how do you choose this? Choosing means it is based on what these things are capable of. Previously, I have given the technical overview of or just a definition. It doesn't help you to understand really what it is. Okay. So now I am going to give use case based definition, which you can very easily understand. Okay. Listen carefully. I'm going to start with the none network. Okay. Now, where this none network is going to be used, it is useful for running scripts. Okay, scripts, and it is, or sometimes we may call it like short-lived jobs. Okay, scripts or short-lived jobs, which does not need network access. Okay, so this is the place where this can be used practically. Uh, you can ask me, can you give any live example? Yes, I will give a live example here. In terms of in any product stack, if you look into that, there are always places when you create a new environment or something, you need to do some seed data in the database. The best use of this type of networking is good for good for seeding data into container storages. Okay, seeding data. When you create an environment of your service and all that, you need some seed data to start with. There are many services like that. So for that, this is a very useful thing. Okay, and I think this one example is enough. We don't need to learn so many examples. When you practically open and see what is a NUN network, you will get furthermore picture. Okay, so seeding data into the container storages, this could be a useful option. Okay, or instead of using the word container storages, I can say database engines. That's where actually it is. So I should have used the word database engines. Database engines. Okay. So this is the use case for this NUN network. Even we don't use it more, but this is one of the practical use cases. Okay. When it comes to the next thing, that is what is that? The host network. The host. The host network is a network which is useful practically in the real implementation. It is used to run workloads like Nginx web server, load balancers, proxies. Okay, so this is useful for run uh, layer 7 load balancers. Okay, and web servers, HTTP servers, and proxies. For all these things, I believe this host network is the best network because it does not isolate the container from the host, because all the network interfaces are still accessible from the container. And that is one of the reasons why this is useful for that. For example, the workload use cases are Nginx. Nginx is the best example, which if you go and run it in a production environment, you don't need an isolation between your container and host machine. You can use this type of a network. And there is another proxy engine called as HA proxy, which you may have or may not have learned. Listen to it. And there is another thing called as Apache HTTPD. So that is also a prominent web server which was used in the last decade. So Apache 2, okay, or Apache HTTPD, Apache 2 HTTPD. Okay, so these are the workloads which you can use with where this host network can be more useful for you. Okay, and if you go to the other thing, that is the bridge network. The bridge network is mostly useful in running the development level environments. So this is useful for standalone Docker engine, standalone Docker engine running dev environments. Okay, or dev or some kind of a non-prod environments. Okay, so that's where this is going to be useful. The bridge network. We will be using the bridge network comprehensively to achieve isolation and also to develop containers and so many other things. Okay, so bridge is a very useful network and a promising network which works on most of the Linux machine without any customization. Okay, but IPVLAN, macvlan, and all does not work that way. Okay, and then when we come to the IPVLAN, okay, let's say the IPVLAN and the macvlan, these are good to replace the virtual machine infrastructure completely. Now listen carefully. This macvlan and IPVLAN is good to replace. So both these things actually solves the same purpose, but with small differences. That's all. So you may be running a virtual machine based infrastructure so far in your company. Okay, but if you want to replace that entirely with containers, these two networks will be very useful for you. So this can be if you want to replace virtual machines, then you have to consider these two types of networks. Okay, because what this macvlan and IPVLAN can do is like it makes your container a real device inside your network, but other networks can't do that. Okay, so this helps you to replace your VM infrastructure with containers. Okay, helps you to replace your VM infrastructure with containers. And how that makes that is possible means it is possible by making containers a real device in the network. Okay, this is possible by making containers like a real devices in your network. In your network means I'm talking about the LAN, in your LAN network. Okay, that is why it is called IPVLAN and macvlan. Okay, so this is the use of this LAN networks that is in the Docker. Okay, so it makes your container exactly an equivalent of the VM. So far, with using all these networks, containers need the support of the host machine for all these. Okay, but here it does not need the host machine support, so it will be able to use the host machine and become a real device in the local network which you have, which is the router. Okay, in that router you can see the container itself as with the proper IP and MAC address and all that. And then we have this overlay network. Okay, so overlay network. So overlay network is suitable only with Swarm cluster mode. Okay, so this works when you are doing Docker Swarm implementation. Okay, Docker Swarm cluster implementation. Here only it will actually work. It does not work in the basic standalone Docker host and all. You can't create this one. It is not possible. Okay. So in the clustered mode, when it is working, it is otherwise called as multi-host networking and all that. But pictorially, if you want me to say that, it is a cluster network. Okay. It is a cluster network and it couples the Docker engines from different hosts. So that's how this implementation works. It couples or say clusters Docker engines from multiple hosts. Okay, so this is how you can choose this type. Okay, so if you want to go with simple running scripts and all that, you can go with this. If you want to go for HTTP layer 7 load balancers and all that, yes, you can go with that. Suppose if you want to run your microservices in a dev environment and all that, you can go with this bridge. Suppose if you want to replace your VM infrastructure with container like a physical device in the network, you can go with this. And if you want to go with the Docker Swarm cluster implementation, because I think I need to put one more word, Swarm cluster implementation, which is a suitable thing for production. Okay, running highly available prod and non-prod environments, you can go for this Swarm cluster. Okay, because if you go for standalone Docker engine, you can use it for development purpose and learning purpose, testing and all that. But the standalone Docker engine cannot provide you an high availability. Okay, so you have to go for either a Kubernetes cluster or you have to go for either a Docker Swarm cluster. Then only you can get this thing right. Okay, so this is how you select. Okay, so what I've been trying to say is choosing the network based on the different use cases. So which is what I am trying to explain here.